Right, I'd like to say good afternoon, but I think it's good evening. Most of the music late. And if I could ask you to turn the music down so that we can focus.
Sorry, I think
They need to isolate that music stream. Here we go. Right. Good evening, everyone. Thanks for having me. I'd like to just do a couple of introductions and maybe set out the format that we're going to run this masterclass in. My name is okay. Lots of heavy breathing there for the wrong reasons. So I'll take us through the process that we're going to run through. Quick introductions. My name is John Hamlet. I'm the Chief Revenue Officer and VP of Sales for CyberSOC. But I have a couple of decades in cybersecurity, financial crime, and nation-state intelligence work. I'd like to introduce my team, my colleagues from CyberSOC. Awoyemi. Sorry, I told you I'd butcher the surnames. He's the head of our cyber labs, cyber threat intelligence, incident response team at CyberSOC, our senior manager in the department. And then we've got Olusegun Dorojai, who is one of our CTI analysts, and Abdul Rashid Olawale, who's also a CTI analyst. These guys have put together a presentation. That presentation is going to be the advanced threat actor analysis and specifically attribution through AI-powered insights. Sorry, if we could close that door, please. There's some feedback coming through from the back. Through AI-powered insights. And ultimately, what the guys are going to go through is the presentation. I will act as a facilitator. If there's any questions, I will back up the team. But I'd like to stress that this is their work. This is their project. It is their idea. And I think congratulations to you guys for getting such high scores in terms of your models. And they will take us through the problem. Maybe you can just progress the first slide. Okay, so they're going to take us through when the dimension comes through. Are you on the Wi-Fi network or are you on those mobile hotspots? Just a second, bear with us if you don't mind. Internet connectivity at the Echo has been something to be desired. If you share. Great, thank you. So it'll take us through the problem, why AI is being used for threat actor analysis, some of the techniques, etc. and then through the research scope, the data processing methods, models used, results, etc. Right? We are going to show some of the live code that was used. And we can even talk about the costs and the models, etc. And with that, I'll keep myself quiet and hand over to Niall. Thanks, Niall.
All right. Thank you very much, John. Good evening once again, everyone. Yeah, before we move to the outline, without wasting our time, I feel there's a need for us to understand why this topic. Yeah, of course, the theme for the Zenith Bank Tech Fair 4.0 is embedded finance, cybersecurity, and growth. The first thing, we are here because it's organized by a financial institution, right? But then we can see the word cybersecurity there, and they are picking a theme that has to do with artificial intelligence. So how do we merge these three together? As John has rightly said, we work in the cyber threats intelligence department, and when it comes to cybersecurity and finance, the first thing that comes to your mind is how do we link these two together, which is threat actors, of course, fraudsters, scammers everywhere. So how is the impact of AI going to help cybersecurity in protecting the finance sector? That's basically why we are here. So like you said, we are going to be taking you through the line of codes, the model. We actually have a high success rate in this. And just before we move on, I would like to give us a simple life scenario so that we can picture what we are talking about. So in cybersecurity, we have fraudsters, like I mentioned, right? And we have what we call, from the topic, we have advanced threat actor. So these are people that are obviously in your network, and they might be there for weeks, days, months, even years, and you cannot detect them. So why are we here? What are we actually protecting? What are we securing? So we need to understand that there is actually a problem, which is the problem of advanced threat actors sleeping in some systems, and then we have cybersecurity professionals out there that are telling us that they are securing the world. So what do we need to understand? The life scenario I'm going to give you is there's something we call takedown as part of a service. So let's assume a threat actor is creating a site, fake sites, for example, and the person is reaching out to your customer for them to use that particular platform to carry out a transaction. And then you decide to report to your cybersecurity team, and then decide to take the website down. The fact that this person is advanced, this person knows what he or she is doing, you can actually spin up another website, you understand, to also carry out similar action. And of course, we have a lot of people out there, even with the cybersecurity awareness, we have a lot of people that still don't adhere to these instructions that we give them, right? So that's the reason for this. This scenario is not something that is just off the book. It's one of the cases that we experienced, and I felt like, okay, this is even the better example to use for this project. So like I said, we have this guy creating several websites, right? And then he keeps on doing the same thing. However, we notice that there are some things that this guy is doing that is consistent, that is persistent. Now, another thing we need to put into consideration here is we want to try to manage the human resources. Like, you don't have to do the work manually. So, because every time you need to go investigate this guy, what's he doing, when is he starting, when are we taking it down, then starts writing a whole lot of reports. So instead of you doing this, even before the guy could successfully reach out to a finance customer, let us put it that way now, in this case a bank, before the guy could reach out to the bank, you have a model that is actually capturing what the guy is doing. Like, it's basically taking the action and is acting before you even see it. So you can then go back to analyze what has happened and the solution you provided. So that's basically what we are doing here. So we are picking a model to understand how a threat actor works. We try to analyze them. We try to get some of their attributes, and then we try to use AI in solving the problem. So because of the time, I'll be handing over to Olusegun, who is going to take us through the outline that we see. And afterwards, Abdurrashid will be taking us through the models so we can have enough time for question and answer. Thank you very much.
Thank you, Adedayo. So yeah, a lot of us during the course of the session might
from the morning up to this moment. We heard about AI. What's up with the AI? Okay, so this master class is just going to introduce you how we can be able to use AI to be able to take hold of threat actors. Okay, you know, in the rising tech space today, we have a lot of technology that is actually advancing. Okay, we have phishing, we have phishing, we have what they call it, different activities that are carried out by these different threat actors. Okay, so where AI comes in is we have a lot of data set. Okay, so this data set, for we to be able to scale this data sets, we need to use AI powered inside. All right. So threat actors are leveraging diverse and advanced methods. Okay, just like I said. Okay, now the first thing is before we use AI, there should be a problem. Okay, not just use AI for anything. All right. There's always a problem to solve whenever we are using AI. Okay, so the problem we are trying to solve here is we have different activities that is being carried out by this threat actor. So as you can see from the screen, you can see that this particular threat actor is carrying out phishing, is carrying out Trojan, is carrying out information theft and the likes. Okay, so how can we be able to solve these challenges using AI? Okay, because by the time you're trying to handle this threat actor, you see a different means to carry out malicious activities, especially in finance. Okay, so for this project, we didn't say that for this project, we're looking at Nigeria threat landscape. Okay, we're not looking at the global threat landscape. So what is particular in Nigeria, just like what Adedayo said, from our experience, it's mostly threat actors creating web pages and making communications to people who have banks, who have credit cards, and the likes. So now, what are these challenges that AI is trying to solve? Okay, now the number one is attribution complexity. Okay, so because of the complexity of this data, it makes it very easy for conventional manual method to be able to get hold of these threat actors. Okay, so by the time you want to analyze these threat actors manually, you see that it's become very difficult for you to be able to analyze them manually. All right. The second one is rapid evolution, evolving technique. So as technology is growing, okay, there are a lot of sophisticated ways these threat actors are using, okay, to to be able to scam. I should use the word scam. Maybe I don't know how many of us are very technical here, okay, but to be able to scam normal conventional bank users. Okay, but AI has that capability of this makes it difficult to stay ahead. Like it makes it difficult for cybersecurity companies to stay ahead because as we are advancing, them too, they are also what? Advancing. Okay, so what is the golden nugget for me to be able to solve that? AI. All right. The last one is data overload. Like I said, you have threat actors from experience who open a web page, communicate with A. When the web page is closed, you see communicate with B, communicate with C on Instagram, on WhatsApp, on chat forums, what are the Telegram, and the likes. So it makes this data scattered around, and it makes it very difficult for conventional manual method to be able to cope. So let me slide this. So that's why AI threat actors analysis comes in. Okay, now what are the things this AI does differently? Why are we using AI? So number one is unmatched complex pattern. So AI has the capability to detect hidden relationship and behavior that traditional tools often miss it. Just like I said earlier, okay, AI has that capability to be able to correlate differences and give a meaningful insight on it. All right, but manual stuff cannot do that. So that is the main reason why we are leveraging AI for threats, advanced threat analysis. The second one is adapting to local context. Okay, so AI has that capability to understand Nigeria's unique threat landscape. Do you understand? Remember here that our scope is Nigeria because it's Nigeria. We are all in Nigeria. Okay, we are trying to battle with the threat actors in Nigeria and their advanced technique they use. The third one is handling massive data. So AI can actually scale. AI can process as large as trillions of data. It can process both structural or unstructured data and make meaningful insight from those data, right? Then we also have proactive defense. Okay, so by using machine learning capability, we can actually be able to make predictive analysis for different charts. Okay, because our scope, there are a lot of threat actors activities. Okay, so by the use of proactive defense, we can be able to understand their pattern. We can be able to understand how this guy charts. So, for instance, you can be able to understand how these guys chat, okay? So for instance, you have A, B, C, D threat actors. Okay, now we are all humans. The way a threat actor A will chat to this person will be the same way you chat with this person, the same way you chat with some other person. So by using AI can be able to understand the pattern at which a particular threat actor is communicating, despite wherever the person is communicating the information in. If it's Instagram, Twitter, what have you, forums, and the likes. That brings us to AI technique for threat analysis. So we have different techniques that are not related to just this three, but for the course of this research, these are the three techniques we are actually going to use. Number one is text analysis, second one is voice analysis, and the third one is gate analysis. So I'll just call on Abdurrashid to throw more light on this. So we're specifically focusing on the threat analysis. That's where our model is being built upon.
I just want to add something in terms of the reason why we're using AI. So yes, it's to identify complex patterns. Yes, it's to be able to crunch that data. But one of the important aspects of cybersecurity is reducing the time to resolution, right? So reducing the dwell time that an attacker is in your environment and that an attack is in process. So cybersecurity doesn't just affect organizations, it also affects individuals. And part of what we're doing here is being able to identify, for example, someone that might be committing wire fraud. Wire fraud is any type of fraud perpetrating over an open communications platform. So, for example, using Facebook, using WhatsApp, using even the internet to commit fraud is actually a form of wire fraud, right? So, someone trying to scam you using a website and maybe acting as a tech support person, for example, or a banker, or something along these lines, and trying to gain credentials to a banking account, to account takeover, things like this. These all fall under cybersecurity, all fall under wire fraud, and so we are seeing a massive increase in cases of cyber-enabled fraud. Okay? And that's a global problem, right? But very much so in, I would say, less mature cyber mature organizations, cyber mature countries. In Africa, although we are a very high uptake in terms of tech, we adopt tech quite quickly, we don't deploy tech very well. Right? So we really start using, let's say, 10-20% of the technology aspect. And then the rest is kind of poorly implemented, and our policies and processes tend to be relatively relaxed, meaning we don't close that, we don't do the observe, orientate, and then closing that loop in terms of policy revision, we don't do very well. So, the use of AI allows us to use our resources more effectively. It allows us to close that gap in dwell time, right? Reduce the time to incident, extending the amount of time someone's in your network, the amount of time that an attack is in progress. Right? We can stop if we can identify an attacker and we know their methodology and the type of tips and techniques, for example, that they use in that attack, then we can become a lot more proactive versus reactive. So being able to identify how an attacker or an attacking process means that we can identify that attacker. Attackers are lazy. I've been an ethical hacker for 18 years. We all reuse the same code. We reuse the same type of attack. We reuse different scripts. And we reuse the same type of language. Why? Because we don't want to go and recreate something for every single different type of attack that we use, because it's unnecessary. Okay? With the use of AI as a defensive tool, us being able to provide attributes and really attribute against those threat actors in a rapid manner is what is critical. Thank you.
Okay. Can you hear me, please? Thank you very much, sir. Just like I mentioned earlier, my name is Attribution. I will be taking you through the part of the
So,
28.
I am going to talk about the AI techniques for the threat analysis that we have here. So, for the purpose of this particular masterclass, we are focusing on this three. We are focusing on threat analysis, we are focusing on voice analysis, and we are focusing on log data analysis. But more importantly, we are actually delving into the text analysis. So one of the problems we see out there is the anonymity of these threat actors. All these threat actors, what they do is the first thing they have to do when they want to attack you or they want to attack a company is that they anonymize themselves. So they probably use VPNs. They don't tell you who they are. My friend guys here wants to go to meeting today and tell him, I want to scam you. So the first thing he has to think about is, how do I make sure that this person I want to scam does not know who I am? And that is what the problem is. And that is one of the solutions we are bringing out. So let's talk about the text analysis. First, let's say the most prominent way a threat actor to attack you is by interacting with you as a person, social engineering. So one of the ways they can do this is by texting you, speaking with you, and trying to lure you into their private scam. Another thing they can do is to call you. That's the voice. So they can call you on phone to speak with you, to interact with you. Another way they can do this is to physically. But what we notice is this, that during these three processes, the threat actor tries to anonymize himself, just like I mentioned. They try to make sure that you don't see them, you don't know who is actually behind it. When they text you, they try to make sure they use VPN. You don't know who is speaking. When they call you on the phone, they sometimes use voice over. So you don't know who is actually speaking. There is an advancement in artificial intelligence right now that can make me call you and I can sound like him. I just need probably like 10 minutes recording of the voice. Like I give it to the artificial intelligence, and then it can give me a voice that when I'm calling you, I will sound exactly like you. So those are the things. Now, we have to use artificial intelligence also to combat this, and that is what we are here to do here. The third one is the data analysis. This one speaks to the cameras. A lot of people here knows there are cameras around here. If any threat actor enters this place, now what they do is the first thing they will have to do if they want to carry out a threat is to cover their faces, use face cap, try to beat the camera. But now, with the gate analysis, for instance, now, with the way the threat actor works, now we can know this is this person. Everybody has a unique pattern. The way we talk, the way we text, the way we move. Now, the way we move here, and artificial intelligence can actually take into consideration the features of a person, how broad the shoulder is, how fast a person moves, how rapidly walks, how staggers, does he have a wounded leg? This artificial intelligence can take that into consideration and identify unique individual one by one. Then it can say, this is this person, this is this person. Now, this is the anonymizing them. They've used artificial intelligence, they've used their senses to anonymize themselves, but we are using the same artificial intelligence to de-anonymize them. Now, we are going to talk about the text analysis. This is what we actually focused on, and this is what our project is about. Okay, so our research is on the text analysis, and what we decided among our team is to look at the current problem that faces you as a Nigerian citizen and the bank as a Nigerian bank. So we have to look at what is the most common ways this threat actor actually attack individuals, especially in the financial sector. So what we notice is this, that the threat actor, what they do is they sometimes impersonate the customer care. of the bank. If you go to any Twitter page right now, and you type on Twitter right now, to say, okay, my Zenith bank account has issues, you are going to definitely, I'm 100% sure about this, you're going to get like 10 different bots telling you, there are customers who part of Zenith Bank, reach out to us, and I bet you can go and share about the debt. I think. So this is definitely one of the problems with out there. It tries to get you to engage them. Sometimes you may have seen an email that just tells you, hello, Ola, I've actually said what. You have 100 BTC in your account. Kindly log in to confirm, or kindly reply these emails to claim it. These are ways they try to make you engage them. That's the first thing a threat actor wants to do. We have different threat actors. We have ones that you want to get your money. Some just need your data. You don't care about your money. You just want to get your data. It's your data that is very, very valuable. If they can impersonate you, they can get into your account. If they can impersonate you, they can get your money. Some don't want to attack you precisely. They just want you to be a weak link to the organization. Say you are working in critical infrastructure, they can use you as a weak link in their organization. So now, specifically, we know that now, one of the ways the threat actor communicates with you as an individual is by text. Now, that is what decided to be the major focus of our research. How can we de-anonymize these threat actors? Just by them chatting with you, just by us including this chat, how can we be able to know who is behind this chat? Are we able to figure out if this person is this person? Is this Adedayo behind this chat just by seeing this chat? So that's why we decided to use artificial intelligence to train a couple of charts. So what we did was to get a lot of charts from each individual. We trained it with the artificial intelligence model. And the model is 99% with 99% accuracy, is able to detect that this is the person that is speaking. So what we just did was to get a chart of, let's say, Mr. Hay. We gave it to the artificial intelligence to learn from. This is how Adedayo speaks. This is Mr. Hay, Adedayo. This is how he speaks. We gave it to Mr. B. This is Mr. B. This is how he talks when he chats. We gave him Mr. C. This is how he talks when he chats. Then we gave him a model. So it's not a E or a E, but it's very, very familiar. So we gave it a text from a random user and asked it, who do you think is currently speaking? Who do you think is currently talking? And it is able to precisely 99% of the time tell us that this is Adedayo speaking, this is Mr. B speaking, or this is Mr. C speaking. So, and that is how we are able to de-anonymize this threat actor. What we know also is all these threat actors they sometimes call you on mobile phone and they pretend to be top text for support. What our technology do also is to take this voice and transcribe it to get the text, and this can also be used to know who these threat actors are. So, when we how do we go about this? How do we go about the model, the creation of this model? This is a masterclass. So, what we want to do is to walk you through with us on how this model is created. How you also can be a machine learning guy. I'm not actually, I'm a cybersecurity guy with machine learning knowledge. So how you also can be a machine learning guy, and how you also can create a similar solution to this problem. So I'm going to take you through the step-by-step process of how we went about it, so that you also can actually go about it when you want to create a similar solution, or when you want to add to it. So the first thing we did was the data processing after collecting the data. So what we did was to do this. we got a number of people, about 36 individuals, with chats, WhatsApp chats. So we exported these WhatsApp chats of these 36 individuals. Mr. A, Mr. B, Mr. C, Mr. D. And remember, the purpose of this is to let the artificial intelligence know beforehand. We are training it. We want the artificial intelligence to know that this is who has been talking for a while now. That's the problem. So we gave it this charts, these numbers of charts, and for it to be able to determine later on if this is a chart that is it started talking. So the first thing we did was to clean the data. So what do we mean by cleaning this data? The data we got was dirty. Dirty in the sense that what this artificial intelligence wants to learn, wants to take in, is a text. We need basically text. And the text we need are the texts that this person writes are actually combination of a word of this person or a sentence, words of a person to make a sentence. So what we did first was to remove links from the text, the corpus of text. There's a lot of text there, charts between a user and another user. So what we did was to remove URLs from that data. We remove phone numbers from it. Then there are emojis, of course, inside this lot of text. So what we did next was to take each of these emojis to turn them back into words. What does the emoji mean? One thing is an emoji that has crying face would mean crying, right? So we took this emoji that probably literally shows crying face and we turned it into its equivalent word, which is crying. Then we did stop removal. Now, there are some words that are common. There are some words that are common that everybody uses. Remember, the purpose of this project is to make the artificial intelligence learn uniquely how each individual talks. So if a lot of us here are using we talk a lot and we are typing. We said, hello, hola, how are you doing? Hope you are fine. So these are texts. This is the way I talk. I think I could talk differently. Probably every time he wants to greet someone or he wants to converse with any other person, is via text. What he has to say is, hey, what's up? That's uniquely applicable to Adedayo. Anytime Shegun wants to talk, probably he say, hey, bro, that's what identifies Shegun. That's a pattern that's actually Shegun's owns. So what we want to do is to remove the common words that everybody, regardless of the person, what they use, such as D. Everybody uses D. This D, or everybody uses is. These words are words that everybody uses. This can actually produce the data by Adedayo uses D. We can't use D or is or the number of is or D that Adedayo uses to identify Adedayo. So that is one of the reasons to put them. Then what we did was to tokenize the data. Now, a machine learning model only use the number underneath the hood. I'm going to talk about how the model works. But just know this, a machine learning model is built with number underneath the hood. So we have to convert the words that is the equivalent number. So tokenization means that we take a unique number and we represent it by a unique word and we represent it by a number. We take hello, for instance, and we represent it uniquely with 10. We take how, for instance, we represent it uniquely with 11. So that is tokenization. It's like now we move to the methods and the models that are used for this project. Now, what are the methods that the model does? But you may ask me, especially people that are not technical here, that what is actually a model? What do we mean by models? And also, I've been saying artificial intelligence. I've actually been using sometimes. I've been saying in the word because we are using a human term for this artificial intelligence. Now, you have to ask, how does this artificial intelligence, how do they learn? Why are you saying learning? It's a computer, for God's sake. Why is it learning? How does it know that this is what happens? And of course, they learn. A computer learn. That is it. So, and how do they learn? They learn with these models. So we are going to say something now. Say I have a sequence of numbers, and I will want probably someone to tell me what's the next sequences. Say I have 2, 4, 6, 8. What's the next one? 10. Good. So this is a pattern, and you are able to give me the next. You are able to predict what the next number is. So can someone tell me how you are able to know that I am probably thinking about 10 as the next one number? Thank you very much. I think everybody gets that. So very good. And this is you learning. You just learned. You learned that I've been using 2. I've been adding 2 to my previous number. So the likelihood of me adding 2 to my next number, to get my next number, is a lot. That is the percentage that I'm talking about. So percentage ranges from 0 to 1, or 0 to 100 in our case. So the percentage that I am going to call 10 as the next number is very, very high. And that is why you predicted was 10. And that is exactly the same thing artificial intelligence does. It learns the pattern. Our brain learns pattern. A brain of a cybersecurity scientist, cybersecurity analyst, for instance, learns cybersecurity. It learns pattern about how to hack, how to secure, how to do stuff. That is what it learns. Now, the artificial intelligence also is learning a pattern. But why do we use artificial intelligence? Why not just I give you another number, say 15, 17, 33, 80, and 10. And I ask you to figure it out, what the next number will be. This is now getting very, very stressful for you. And this is why we now need, okay, we have a lot of time to focus. We still have a lot of time to do better things than start calculating numbers. I can't be giving you numbers all day and be asking you to figure out the next one. So you can better use that time to do a lot of things, better things, than to use it to predict the next number. So that is why we give this task to artificial intelligence, to do what? To recognize patterns, to think about, okay, they learn. What is the possible pattern between these words? What is the possible pattern between these numbers? So that is exactly what they are doing. So what we are giving this artificial intelligence is, what is the pattern at which this human talks? Does he use hey bro? Does he use hello guy? Does he use how are you? How often does it talk? Is this person a talkative? Does this person, when you type hello, does this first actor replies with, hey, how are you, bro? I'm fine, and everything? Or does he just say hello back to the person? These are patterns. These are patterns we want this model to learn. Now, based on the pattern it has learned, based on what it has learned, it is now going to tell you that Adedayo uses a lot. He uses broken English and says, how you day now? This is likely going to be Adedayo. Now look at this. I don't know, this is not clear. No. So what we did first was to take the corpus of data the data we have, the text, the sentences of each individual. And we try to look at what is the most frequent word that each of these people uses. Now, I apologize about this. I don't know why this is showing like this. Yeah, but people online should be able to see it. Now, here is the name of the person, the name of the people, the name of one of each of the name of the people that will text the collected their WhatsApp chats. And here is the common words, the most frequent word that they use. Now, we see here that Adedayo uses day a lot. D-E-Y. Adedayo says, Alpha, how you day now? You don't day yet. Stuff like that. You remember we said they are training on Nigerian data. So that is why we chose the broken English. That's why we chose Nigerian guys to actually train this model. Also, we have Anita here. Apologies, you can't say it. Anita uses Parfait a lot. Anita is one of our guys there in the office. And she sells Parfait. So she literally asks everybody about Parfait. She likes Parfait a lot. She asks, are you guys buying Parfait? Are you guys buying Parfait? So remember now, if this model sees Parfait tomorrow, who do you think is going to say, is likely going to say the same result? Definitely Anita. So Shegun also uses SAR a lot. Shegun here calls everybody SAR. So if he sees a baby today, he's going to say SAR. Hello, SAR. So the most frequent word Shegun uses is SAR. And that's what we are able to say here. Now, we not decided that, okay, we have the most frequent word of these people. What we did now is to go ahead with the training of the model. We want to train the artificial intelligence. Okay. Now, we use different methods for this training. We did the BETS transform. We used the BETS transformer. That's a model by Google. So this model, what it does is this. Now, Google has trained a lot of work. It has trained this model. It is we call it a pre-trained model. Google has trained it based on everything you've been texting, every word that a user has been texting. So Google has actually made this model publicly available for everybody. So what we did was to go online and we get this open source model. And we trained upon the words that we have from our own company. So why do we use this BETS model, this BETS transformer? The reason we use this is this. This particular model, this particular artificial intelligence model, understand what you are discussing about. It does not just understand that this is this is the most frequent word in this text. It understands that this person are discussing about credit card fraud. It understands that you are talking about seeing the movies. You are talking about buying something. So this model actually understands it. You understand? So that is one of the reasons we train with this model. And we ask this model to look at the text. And we need to be able to predict that who is the next person? Who is the person that is likely saying these words or this sentence? Now, another thing we did was we used stylometric analysis. Now, what do we mean by stylometric analysis? We took the length of the text of each individual, the common words, just like you saw. The numbers of adjectives they use. A lot of people, sometimes, as a person, you use a lot of adjectives a lot in your words. You look at the numbers of verbs you use, the length of the sentence. Does this person like blowing grammar a lot? We look at that here. So we took the stylometric analysis of this person to look at the pattern at which this person actually discusses. And now, based on that, we gather this data and we feed it into a machine learning algorithm for it to learn also. Remember, it has to learn the pattern at which this person talks. This person uses day a lot. We can't use that to say this is definitely Adedayo or this is definitely Shegun because of the day. then a lot of people speak broken English. We have to look at another pattern in the word. We have to look at, does this person like talking a lot? Does this person uses a lot of long text? Does he use grammars? Does he use vocabulary and stuff like that? So that is why we take this cybernetic analysis and feed it into the machine learning, for it to learn the pattern and decide, okay, this is who is speaking. Now, another thing we did was to use the Globe word embedding. So what we did was to take the Globe. A Globe is just like a web embedding. It's able to map that a king is a man. So it gives context to the word. It understands. This makes our model understand what you are discussing. Are you talking about a king? Now, if you say a king should not be a female, it should be a male. So this particular Globe model, Globe embedding, makes us understand it. So that is basically what we did. And I'm now going to show you the model. So I'm going to show you the models and how we are able to achieve our percentage. So we are able to get 99% accuracy. That means 99% of the time, sometimes we got 99.5. That means 99 out of 100. So we gave it 100 words. We gave it 100 sentences. 99 times of the 100, 99 times of the 100, it got that this is the person that is actually talking. It got it right. So, so how can this be? How can we use this? So the way we can use this now is this. Say, for instance, we have a chat of a threat actor. He has been creating WhatsApp chats and he has been chatting with some of our clients or you in particular. What you just have to do is to export this chat, give it to the model. The model is going to take it, and the model is now going to compare it with, it's going to train on it. It's going to learn how this threat actor has been talking. And this model is now going to check, for instance, now that, okay, say for instance, now we encounter this threat actor again in the forum. I want to compare in our forensic investigation that is this the person that scammed you or not? What we just have to do is to take the sentence and check, and we'll be able to figure out that this is actually the person that actually scammed you. So that is it. So as you can see here, this is a sentence, and we're able to get who said a particular word. Told us that, hey, this is the person that said this word. All right, so that's it for me. Thank you. So if you have any question, I will hand over to John now.
Thanks. So, one of the things about AI is that we have to do this at scale. Now, important parts of the model that they used was the pre-processing of the data, right? Parsing of the information, the pre-processing of the information into a structure. Now, the structure of data needs to make sense and needs to have consistency. If you're not re-looking at the same type of data in the same format, then systematically the AI is not able to interpret it in the same way on a consistent basis, meaning that I'll get out of your way, that the output that the AI provides will be flawed. Okay, so there are some potential issues in terms of use of AI, and the number one is the use of unconstrained AI, right? Or using AI in an unconstrained manner. Unconstrained means that it's used for every general purpose that you're trying to solve. And not every single model, as you will see, will give a consistent effort, will give you the outcome that you're trying to generate. So the model needs to use multiple scenarios and multiple, let's call it algorithms, in order to get the result that you deal with, or that you are searching for. So using AI in a constrained manner, meaning through a specific process, okay, that you've defined, will yield much higher accuracy. And this is critical. When you're dealing with big data analysis, you want to get that consistency, right? You want to be able to say that I have a confidence level, and that confidence level is extremely high or very high or high that you're looking for, right? Anything above, let's say, a 90% confidence rating is very good. You know, these guys have used a small data model or a small data sample, and even though they've used a small data sample, they've been able to get very high accuracy. As that data grows, that model must be agile enough to be able to process data so that they can get that consistent result. So I just want to say that you know, these guys used a total of $11 US to generate the model, to generate the capability, and to get, you know, virtually or very close to 100% accuracy. So you don't have to expend massive amounts of money in order to use AI as an effective tool to, in this case, enhance the human's ability to analyze the data and provide attribution, right? And there's many use cases here that this can be used for. We talked about, you know, financial systems and financial environments, cyber-enabled fraud. We talked about wire fraud. We talked about identifying, for example, threat actors that are sending the same ransomware note or that are using similar language in phishing attacks. Okay, there's many types of uses where AI can be used in order to crunch the numbers for a specific output. And this is something that we specialize in CyberSOC. And so I just want to say to Zena, thank you very much for allowing us to come and do the masterclass. We hope that you have found this very valuable, and open the room for questions, 1 or 2 questions.
What is the disadvantage of using AI?
Sorry?
What is the disadvantage of using AI?
Okay, so the question was, what is the disadvantage of using AI? Well, in this case, you know, there might be privacy issues. If you don't have, if we are scraping information from a website, you must be able to have privacy disclaimers that tell the end user that the system that they're engaging with, for example, is going to be used for artificial intelligence analysis. It's going to be used for things like attribution, etc. And whether or not the user that is identifying or using that system understands that or not is not really up to you, but there could be privacy concerns, especially if the data that is being used isn't necessarily tokenized. So in this case, we use tokenization in order to minimize on the privacy aspect too. So that's one. It might be whistleblowers. There might be another reason or another potential disadvantage is data bias. So if I'm an attacker and I know that you are using an AI-based tool in order to attribute, I can copy, for example, another attacker's language and text, and I can saturate the systems that I know that you're watching and saturate your honeypots and create a bias, right? And because I'm creating so much noise in your data model, I can slip past by using different language models. But as you start layering the intelligence analysis and different data sets together, so here we just showed you text, right? But if we take voice, then you have an IVR system that is doing real-time voice analysis, and it's doing translation from speech to text. And we're including that in the data model for real-time analysis. And you're doing something like gate analysis, let's say a scammer walking up to an ATM, and there's been constant attacks at the ATM. You can recognize the attacker from their gate, you know, and maybe a microphone that is in the ATM, for example, and maybe combine that with the text analysis that is coming from the victim that he's trying to scan. You know, now you're starting to get a much more defined picture without necessarily having data bias. Right? Does that answer your question? Cool. Sorry.
Can we ask questions?
Okay, so cloning the voice so that it sounds like me speaking to you versus the actual text, the words that I'm saying and the structure that I'm saying is two different things. Okay, so the machine, the AI is learning numbers. And we are reducing the data processing, we're reducing the numbers.
We need that
the
guy.
text to numbers. Right, so the fact that I use like, or I use another adjective, or I use verbs in a certain structure, and that I speak so much in terms of an answer and my paragraph structure can all be deduced from the speech and transition and translated into text. Okay, we then use that text to identify your speech pattern, not your vocal pattern. Okay, so I can sound like or Abdul Rashid, for example, on the phone, but how I'm saying it, what I'm saying specifically, would be unique to me. Answer the question. Oh,
Can I use it?
thanks, Ben.
Hello, I want to ask a question.
So what roadmap can a cybersecurity enthusiast use in order to get knowledge on the use of AI? Okay, so remember that AI is ubiquitous. You can use AI in just about any industry. From a cybersecurity perspective, you know, it's exactly the same as any other industry. You need to define what you want to attain with the AI. What is the problem that you're trying to resolve and solve with AI, right? Then generally those are big data analysis, pattern recognition, you know, wire speed, processing, machine learning, so that it can provide attribution, etc., and things like that. So from a cybersecurity perspective, define what you want in cybersecurity to solve with first. It may be something like this, right? It may be log analysis, right? You may be training an AI on log analysis for a specific type of attack. And you may want that AI to then generate a use case for you in a SIEM environment to identify attacks in real time. Okay, another use case. There's many use cases that you can do. So my recommendation is understand what you're trying to solve for initially, then go and do your research on AI. There's so much data out there, it's scary. Okay, find the free systems. Google, for example, use Gemini, use ChatGPT, enhance the way that you define your queries. Because if your queries are right, you're going to get consistency. And that's what you're looking for. And test it. I mean, $11 for us over 2 weeks to create a model like this, and we probably didn't even need to use the full $11 anyway. The majority of this came from freeware, from open systems that are available to the public. Just remember one thing. Don't put any sensitive or confidential data into an open AI system. Okay? Don't do it. Don't put a contract in there with company names and things like that, because that system will learn it. And if someone else is querying about your company, that may well come out. Okay. Right? So just be aware of that, that anything that goes into the public domain should be of public nature and public confidentiality. Okay. Okay, so let's start with the first one. The first one was, how do we make sure that we don't become the threat actors? Right? Because the AI, make sure that the AI doesn't become a threat actor. Okay, so the AI will process a task. Okay, and this speaks to some of the ethics around the use of AI. And the regulatory bodies that are starting to put guidelines, guardrails, and guardrails in place, right, for the use of ethical use of that. So training a system and using a system are two different things. Training the system, you need to make sure that the data set that you're training on is related to the output that you are expecting. So for example, using log data and training the system on log data instead of training the system on every piece of data that you can get in the world because you now wanted to interpret log data. Okay, so constrained use of AI is much better use in general use of data. Okay, so that's number one. Don't train a system that's based on, let's say, the public internet, because you are going to get bias. That's a natural bias that we as programmers identifies in the data set of error needs to be induced or ingest in order to get that result. Like, for example, if you look at ChatGPT and Gemini. Gemini was a good tool. They now in the US elections, they asked Gemini to write a poem about Donald Trump, right? And it wrote some nasty poem. Then so asked him to write the same poem about Joe Biden, and it was positive, right? So there was clear bias in there that was programmed by the data that it had sucked up, and a lot of that data had been sucked up by like the mainstream media. Okay, so that's one aspect. Second aspect was what type of tokenization. We've got to wrap it up. Okay, so that have to be the last question, unfortunately. What type of tokenization did we use? I think what's the algorithm that you use? Binary, converts binary. Sorry? Okay, so it was binary, right? And that's basically just for speed processing. Now, if you use an algorithm with that, then you can get around the privacy aspect. Okay. And what we were looking for was predictability. We wanted to be able to find attributes that identifies the threat actor, and then for the AI to be able to predict the threat actor. And then the last question that you had was, okay, so good question. Again, what we wanted to do was to be able to provide a structure that showed you how to do attribution better. Okay. Yes, it was a controlled environment. The reason that we used a controlled environment was because this was the data that we had access to, that we were allowed access to, with permission from all of the people, right? And even though it was on a public forum, these individuals had given their permission. So you've got to think about the real world usage of this. It might be Zenith Bank, for example, using the interactions on Ziba, right, in order to identify potential fraudulent users. They might be committing first party fraud, for example, or trying to identify threat actors that have attempted a fraudulent transaction and are now querying the fraud team or the customer support team specific questions and in very specific types of structures to see if they can identify the thresholds at which the fraud system is picking up the fraud. Okay. And if they're coming in over the telephone, then you can combine the text and you can combine the voice. If you do voice translation, you can text and then combine the text and then process it and then. Okay, you get the picture. Okay. Thank you, ladies and gentlemen. We hope that this was valuable for you.
But before we go to the next session, we want to go to the roles. So you can write
ZB Events 2000. So for those of us online, I'm announcing an email that you can forward all your questions to, so we can respond as well. So I'll take that again for the sake of those online. ZB Events 2000 event 2000 ZB event 2000 ZB
Yeah.
ZB event 2000 at zenithbank.com. But it's not us. ZB event, right? Of 2000 at zenithbank.com. ZB event 2000 at zenithbank.com. So do send it from your email so we can filter the question, get the answer, and send a response back to your account. Thank you so much, Senator. I appreciate it.
Thank you.
Apologies. Did I say at zenithbank.com? Please forgive me. At gmail.com. You know, everything is about Zenith, isn't it? So ZB events at 2000 at gmail.com. It's been a long day, right? ZB event 2000 at gmail.com. Did you get that now? Thank you so much. So we'll jump over.